Welcome to this voting DApp demonstration. Blockchain voting is similar to analog voting that we are used to. The same concepts and processes apply. In order to cast a digital vote, a voter would need to register and prove their eligibility in an election. We could then record that identity on the blockchain associated with that user's crypto wallet account. A voter needs a ballot to cast a vote. In the blockchain, this would likely take the form of a special voting token that would be deposited in the voter's account. The token would have a time limit in which it could be used to cast a vote, after which it would become useless. Casting a vote on the blockchain would involve sending the voting token to a specific candidate address. Sending a token to that address would represent a vote. A simpler way for this demonstration is to register the voter's choice on the blockchain, and only the last vote before the election is ended will be counted. The vote gets registered on the blockchain, where it's immutable, verifiable, and transparent. We can easily count up the votes to declare a winner of an election. Technically, the eligibility or identity verification is a complex process, and we will skip it in this simple voting demonstration. In this demo DApp, the voting host is the one who can start and end a voting. Voters will first need to join the voting by its unique address when it is created on the blockchain. Then voters may cast their votes to a candidate, which is then registered on the blockchain. When the voters vote more than one time, only the last vote will be counted in the voting result. The voting result will count the total valid votes and the votes received by each candidate. Once the voting is ended, no more votes can be casted in that voting. Now, let's go to the IGS box to see how the blockchain voting DApp works. To start the DApp in the IGS box, you may go to explore the voting DApp in the feature box, or type in the URL of the box. You will see the coding pane on the right and the DApp preview pane on the left. Let's go to the full page mode to see the DApp front-end view. In this crypto wallet, I have created more than one account. We simulate account 1 as the voting host who can start and end a voting, while other accounts can vote and view the voting result. Each user account in the wallet has a unique address. Account 1 has the suffix 3257. Okay, let's select account 1 and create a new voting. Once account 1 launches a new voting, a smart contract for this voting is being deployed on the blockchain. Account 1's wallet will be called to pay the smart contract deployment transaction. Once the smart contract deployment transaction is done, the smart contract address will be shown in the voting address box. Other users may join in this voting with this smart contract address. Let's start the voting DApp in an independent browser and participate in this voting. Type in the voting address we just deployed and click Join. We now cast a vote to candidate 3. The crypto wallet will be called to confirm the transaction to vote. When the vote is casted, you can check the result. Only candidate 3 has one vote. If the voters want to change his mind to candidate 4, he may vote again and only the last vote is counted. See the result now, only candidate 4 has one vote. The voter is not the smart contract owner, therefore the close button is disabled. Okay, let's return to our browser and select another folder, say account 2. Account 2 has the suffix 69DA. Account 2 now casts a vote to candidate 4 as well. Now you can see candidate 4 has 2 votes. If account 2 changes the vote to candidate 3, now you can see candidate 3 and 4 has 1 vote each. Because account 2 is not the owner of the smart contract, the close button is also disabled. Let's try to vote by account 3 who has the suffix BAA6. Let account 3 vote on candidate 4. Now, candidate 3 has 1 vote and candidate 4 has 2 votes. Account 3 is also not the smart contract owner, the close button is disabled. Let's go back to account 1 and vote on candidate 5. Now, candidate 3 has 1 vote, candidate 4 has 2 votes, and candidate 5 has 1 vote. Account 1 is the smart contract owner. The close button is enabled. Account 1 can now close the voting. When the voting is ended, any vote will not be counted. See, the result does not change. Candidate 3 has 1, candidate 4 has 2, and candidate 5 has 1. You see how the voting DApp works now. Do you want to know how it is coded? Let's go into the next module, Voting DApp Code Explain, where I will explain how to code this DApp.